All right, so today, everyone have their notes out? We ready to go? All right, fantastic. You have covered this material before, but we're going to be talking about functions. Okay, functions. Functions are going to be the next topic. That's what your next whole unit is going to be on. Okay, you can think of a function as kind of like a mathematical machine. Okay, it's in a number, spins it around, and spits another number out. Okay? So it has a number that goes in. Number is x. And then it spins it around, math to it, multiplies, divides, subtracts, square roots, does all sorts of things to it, and then spits out another number. And that output we usually describe as a y. Okay? Because when we graph it, we have an x value and a y value. Okay? Dumb. All right, so this is my input variable. This is what we call the independent. It's independent because it can be whatever I want it to be, most of the time. Sometimes there are values that aren't allowed, but we'll get there later. Here, this is the dependent variable. It's dependent because what it is, what its value is, depends upon what you gave the function in the first place. Okay? The function is the machinery of what happens to the number. How does it get multiplied, added, subtracted, divided? How does it get changed? And then it gets spit out. Okay? So it's kind of like, in a sense, a little mathematical machine. Okay? So let's have an example of what I'm talking about. Okay, now when I write this is what is called function. Okay? The f is not multiplied to the x. Okay? It's saying f of x. That's how you would read this. This would be pronounced as f of x. Okay, that f can be a g, an h, an r, a w. It can be anything I want it to be because it's basically just a name. Okay, because some problems there'll be more than one function involved, and I want to say this function or that function and not confuse them. Okay, so an example of a function rule could be something like this, something like that. Okay. And what is happening here is that you give me a number, I'm going to plug it in to this function number that spits out. If I did this, what that's saying is every time I see an x, I'm going to replace it with a 5. Okay? So going back to the original function, it would be 3 times 5 plus 2. You see how I just replaced it? That's all I did. Okay? The machine takes in a number, in this case it was 5, and throughout the machine, sometimes we'll see that x a couple of places. Every time I see an x, I replace it with that 5, and then the machine runs, and it gives me a number at the end. Okay? So 3 times 5, 15, and 15 plus 2 is 17. Okay? Do you see how it took in the 5? Hi, how you doing? We good? Okay. Taking a lot of notes there. Okay. So, what would f of, say, -1 be? We're going to plug in -1 every time we see that x. So it's be what times what? Plus 2. And now we're going to get a value out of it. What value do we get? 3 times -1? -3. That's a lousy looking 3. Plus 2 is -1. You see? So this number took in -1, spun it around, and spit -1 back out again. Okay. Now, this and is just one example. I could have different functions do all sorts of different things. Okay? I could have functions like this. See? Here I have x's popping up in more than one place. Okay? And now, by the way, notice that I'm not using f right now. I'm using I don't want to confuse it with the f that I used before. Okay? This is a different problem. Okay? And the name of it doesn't really much matter. It's just so that we can kind of say this function versus that function versus the other function. Okay? And kind of tell the difference between them all. So what do you say about g of 2? Well, depending upon the problem, I'll ask you for different values. Okay, so I could ask you for 2, g of 2. I could ask you for g of 10. And the problem is. And
I can ask you for more than one.
Yeah, I'll ask you for a bunch. I'll use this to fill in a table. Plug in every one of them and come up with one. And we'll do that next. So what do I do here? 2 to the power of 2, which is 2 squared, right? 2 squared is 2 times 2 is 4, and my answer is 8. See how that works? What about if I plugged in g of -2? Now notice what I was doing there. I was wrapping things in parentheses. And that's going to be really useful sometimes, okay? How would I go about doing this one? Whoops. How did that happen? Did I just lose a page?
You'll go down. You gotta scroll down.
Okay, I just didn't go down far enough. You see, by wrapping things in parentheses, I can avoid making little mistakes. What's -2 squared? -2 times -2. +4, thank you, Anthony. -2 times 2. And so what's the answer here? 0. Okay, 0 is a valid answer, guys. 0 is not some magic number. Okay?
If you put -2 in your calculator, if you're using a calculator without a parenthesis, you're going to get -4. That's why.
Yeah, because the calculator doesn't know. Here, let me show you what Mr. Dove is talking about here. Okay, remember what the order of operations says. The order of operations is exponents go first, right? According to this, the exponent is happening first. See, the calculator reads this as -1 times 5 squared. It doesn't look at -5 as a single number. It sees -5 as 5 times -1. So what this thing does is it just says 5 times 5, because that's what the exponent does, times the -1, and it gives you -25, which is not what you probably want. What you want is that, -5 times -5. So that's why I say wrap things in parentheses. And it also avoids you losing negative signs and things like that. Okay? All right. Let's try this one. Let's do and I want f of 0, and I also want f of 2, negative 2.
Give it a shot. Which first pressing is?
So every time you see an x, you're going to replace it with a 0. And every time you see an x, you're going to replace it with a negative 2. Yep, plug and chug, man.
So, plug that 0. Use a parentheses. You're going to calculate. Okay, use the put it in parentheses. You're going to use a calculator.
So these are two different problems, both using the same function. Okay, Brad, what did you get for the first one? Nice. You got 1. Because you did 0 squared plus 2 times 0 plus 1, right? 0 squared is 0, plus 0 plus 1 is 1, right? So for this machine, this function, if I give it a 0, it spits out a 1. What happens if I plug in negative 2? What happens when I plug in a negative 2?
Do the same thing.
So, negative 2, what do I do?
Put the 2
Okay. Plus, right? Good. See what she did? She just replaced x with negative 2 each and every time. Okay? Wrapping in parentheses so we don't lose a negative sign anywhere. Being real careful, step by step by step. And what's negative 2 times negative 2? Positive. And negative 2 times 2?
Negative.
And plus 1. That didn't change. So 4 minus 4?
0.
0. Okay. So there's an important thing that just happened. I gave it a 0, and it came out with a 1. And then I turned around and gave it a negative 2, and it came out with a 1. Functions have one very important rule. And here's the important thing you got to know about functions. For every input I give it, I get one and only one answer out of it. The way that I can kind of put this to you is like this. If you walk into a store and you see two items on the shelf, they could both have the same price tag. That would be perfectly fine. If you walked into a store and you saw an item for $10 and then right next to it was a different item for $10, that wouldn't confuse you at all. Right? Two items can be sold at the same time for the same price. But if you walked into a store and you saw an item on the shelf and you picked it off and there were two different price tags on it, does that make sense? If you had two different price tags on the same item, walk into the store, hey, how much does this cost? Oh, it's got a ticket on it, $50. It's got another ticket on it, says $60. You would go up to the manager and say, what's the deal? Right? That doesn't make sense. One item can't have two price tags. Just like right here, two different items, 0 and -2, they both gave me the same thing. They both produced 1. That's okay. Two different items can have the same price. A 0 and a -2 can both give me 1, and that's okay. But if I put in a number and I get two numbers out of it, I get a problem. Like this. Here, when I plugged in 1, I got 5. When I plugged in 2, I got 7. When I plugged in 3, I got 5. When I plugged in 4, I got 3. Is this a function? This is fine. Is this a function? Why not? Okay, x, this right here, 3, it gave me a 7. And then later on down the road, I asked it for 3 again, and it gave me a different number. And you're like, wait a minute, hold on, there's a problem here. This, two different answers, and that's not allowed. They can't be. They can't repeat. They can't. You can't. It's kind of like, if you walk into a store and you buy a pencil for $1, and then you walk back the next day and the price tag is $2. You're like, well, wait a minute, what happened? Same item should have the same price tag on it. Here you're saying a 3 gives me a 5. That's something wrong. Yes. Yes. Yeah, you will be graphing them. Okay? All right. A lot of times we'll see these kinds of a graph. Take a look at that. Here, 2, if I plug in 2, it gives me -3. If I plug in 5, it gives me -3. If I plug in 7, it gives me 2. Is this a function? It is a function. None of my inputs gave me two different outputs. But if I gave you this, what about this guy? Well, 3 gives me 6, 5 gives me -3, 7 gives me what? 2, and 8. Wait a minute. How does that work? Here you're saying that 7 produces 2 different numbers. You see how that this kind of like starts to fail? Because what we're saying is that 7 produces 2 different things. That doesn't quite work. All right? So when you're doing these kinds of mappings, you want to make sure you see how for the same x value, I got 2 different y values. Input, output.
Guys, if it helps you to write out the order of pairs, you can do that. The order of pairs would be 3, 6, 5, negative 3, 7, 2, 7, 8, 7.
Yeah.
And you have to do that. That's a little more work for you. If you have a hard time interpreting that.
Does that make sense?
So
Bless you.
if you write it out, it shows that it's X.
Right. Where
Or
what?
you think of it if there's 2 arrows coming out of one number, it doesn't work on that kind of
Right.
picture.
It's a mapping, yeah. All functions are mappings, but not all mappings are functions.
So if you have to write them out like that, then do that. I mean, if that helps you.
Mm-hmm.
As long as you're getting the question right.
Yeah, so after you write it out, it's what's
Okay.
this is in
Right.
You see-
It's written once, but there's 2 coming out of it. So that's
Right.
why it's 2 arrows.
Yeah. It's like the number 7 has 2 price tags on it. A 2 and an 8. What about this guy? Is that a function? Right. See how I don't have any x's that are the same? Okay. I can have y's that are the same. That's okay. I can't have x's that are the same. All right. What about if I did that? Yeah, now I have a problem because -5 is going to 1 and it's going to -1. That's not good. Okay?
So even if, so if you can make up it's still,
If it was -5, 1 and -5, 1,
yeah,
then it would be a function because I'm not repeating. I mean, I'm repeating the value, but it's still going to the same value. That's like having two identical items with the identical price on them.
They wouldn't keep that.
They don't do that. They don't do that though.
Not if the economist, though.
No, they don't.
That would just be kind of scary. They try to confuse you, but not that.
No. So if I were to graph these, roughly speaking, it would look something like this. Sort of, that's where everything would fit if you were to look at them on a graph, where I have -5, 1, -5, -1, 3, 2, 7, 2. They don't have to be perfect, but you can see where they would basically be standing, right? They would all kind of roughly be in that area. So it was the fact that if we have one x value, we can't have two y's. It was this right here. That point, that thing right there, where one x value, if I climbed all the way over to -5, around and I looked up and down to see where the graph was, or see where a point was, Cody. Thank you. I get two different outputs. And this is graphically where the problem is. Okay? Yeah, no, you're right. There's a test. And it's called the vertical line test. If a vertical line, in this case my blue line, hits 2 points, then it's not a function. Right. So something like this. Looking at that guy, oh, you gotta wonder. Is that curve a function? If I walk along this thing, do I have any places where I hit 2 points? It only ever hits 1 point at a time, right? But what about if I did this? No, this one fails. Because as soon as I get there, or any of these spots in here, if it fails because of 2 points, you better believe it fails. It hits 3. It always goes forward. It doesn't go forward and then forward again. You see what I mean? So what about something like this? Is that a function? No. Because it fails right here. You can even see it. Boom, boom. The axis was a vertical line. And that failed. It failed at any of these other spots too. Fail, 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 fail. What? Oh, yeah, sure. You see, I don't know what's going on with my smartboard software, but I can't adjust anything. Is that a function? No, it is not. Yeah, it hits at an infinite number of spots. Vertical line is not a function. What about a horizontal line?
Yeah.
Sure, horizontal line is fine because it only hits one spot, right?
Really, any line guy that's not vertical is function. Right? Any straight line, right? As long as it has no curve, it will always be function. It's not vertical.
All right. So, just to get some vocabulary in here. This is what is called my domain and the range. Yes, these are your x's. These are your independent variables. These are your y's. These are your dependent variables. Function or not a function? Yes. Function, not a function.
So, so,
Not a yes. Oh yeah,
so,
it is.
think about it.
Oh, okay.
Remember, with these ones, we want the 2 arrows coming out of the same number. None of them have 2 arrows coming out. Right? It doesn't matter. The Y's don't matter. It's the X's.
See how that works? None of my X's are repeated. They're all just going to A. Everybody goes to 8. Big deal. You know? What do you give me? It goes to 8. That's okay. It's just when one thing goes to 2 things that it fails. Question? Does this make sense? Okay. Last thing for right now. So, the domain is what you're giving the machine, what you're giving the function.
How many inches are you going to have here?
You're going to plug them in and you're going to get outputs, right? Your inputs are your domains. Your output is Brandon's gum in the trash. Finish it. And that's how you find your range. You plug in your domain, spin out your numbers, boom, there's your range.
So how many inches are you going to have? Right? So when you're doing this, okay? How to do that? Just plug them into that function right there. X squared plus 2. Instead of X, what do you put? First you're going to put 3, then you're going to put 2, then you put 4, then you put 6. Right?
Right. And then you just crunch those numbers and get your values, and those values make your range. The thing you put in.
Those are your domains or your inputs, right? Your inputs are the domain. All the same thing. Put those into the machine. How would it happen?
In goes a number, out comes a number. Input, output. All right. So 3 squared plus 2. Nice. 2 squared plus 2. 4 squared plus 2. And 6 squared plus 2. So to answer the question, what is the range? Well, the brackets around it.
No.
In this time, the parentheses didn't much matter because I wasn't dealing with any negatives. But I was just keeping them in there to keep the pattern going. Normally when we have a list of numbers, we write them in between those squiggly brackets. They call them braces. Okay.
They're usually in numerical order too, right?
Some people it matters to it, but to be honest with you, I don't have a preference.
Multiple choice though, like on a test, it's probably will be. But
Yeah, but it's not wrong. It's,
But not you need to know that you just need to have one.
okay. Are we cool? All right, so what we're going to do is there's a quick little 2-question little exercise. You're deciding if it's a function, if it's not a function. If it's not a function, you're going to tell us, you're going to write down where it went wrong. Okay? So like for example, this one went wrong. This one went wrong because of the 7 going to the 2 and the 7 going to the 8. Okay? So it's just a quick little thing, and then once you do that, then we'll be able to give you your homework, and you guys can work on your homework, and you'll be done, hopefully, you know, before class lets out, and this way you won't have any homework tonight. Sound good? Awesome. All right, this episode of the Bronco Show has been brought to you by the number 4 and function rule.